Thank you, Doug. Thank you, everybody, attending this presentation this afternoon. What I'm going to be talking about this afternoon, we're going to be talking about chrome rubber production. This presentation has been divided in three different segments. First, we're going to be talking about ambient method of production of chrome rubber. Then we're going to go on with the cryogenically producing chrome rubber and some of the technical aspects which impacts the performance of asphalt rubber based on the type of production and size of the chrome rubber. This is what we are dealing with. This is a cross-section of the tires in a basic tire construction. You have, of course, rubber. You have nylon, Kevlar, different types of fibrous material, and metal or wire. And also we are dealing with a bead wire. Because of the shape and construction of the tire, we have a very great challenge as a tire recycler to produce chrome rubber based on the specification required for asphalt. Why we are talking about different types of production method? The impact of the different production method, it influenced the elastic recovery of the chrome rubber we're producing. The buffing process, which is coming from retreading of truck tires or passenger tires, based on analysis was done, you're looking about elastic recovery of 21%. This is a great research was done by Australian Research Institute finding these findings. You're looking at ambiently ground chrome rubber. If you look at it under microscope, you're going to see a torn edge with large surface area. And we're looking about the elastic recovery of 35%. Cryogenic rubber is got a smooth surfaces, lower surface area, and you're looking about elastic recovery of 6%. Mainly for asphalt purpose, we are using chrome rubber produced by ambient method, and cryogenic rubber is being used for sport surfacings such as soccer fields and for artificial fields. The use of cryogenic rubber usually is being mixed with sand and is being used in artificial field. First, we're going to start with the ambient production method for chrome rubber production. We're going to be showing to you three different departments when a whole tire goes all the way from whole tire down to chrome rubber to be used for asphalt rubber. The first department is shredding department. We're looking, of course, tires, all different types of tires. The challenge in the shredding department, when you shred, when you shred at 600 tires per hour, you cannot distinguish between the different size of the tires and the type of the tires. Usually shredders, you're looking about anywhere from 7 to 50 rounds per minute is a slow process of shredding process. In this department, the whole tire gets shredded down to 2-inch nominal size. However, for different application, you can take it down to 1-inch or even larger sizes. That's a classification of the tires. When it goes to a classification table, and it would recirculate back to the shredder until we get to the nominal size of the 2-inch we need. In this stage, the rubber and the steel and fiber is all together. All of the material is all embedded together. So with this department, we're looking about capacity of anywhere, equipment available anywhere from 600 tires per hour to 1,000 tires per hour. We're taking the whole tire down to 2-inch size. The next department, we talk about granulation department. As we go to the next department, also the use of the equipment is going to have a higher RPM. You're looking the RPM on the machine, anywhere from 80 round per minute, the cutting device, all the way to there are machines available to 400 round per minute. The significance of this RPM is we all have heard about safety and fire problems with tire recycling. As you get to higher RPM machine, the chances of fire is higher. So in the shredding department, the chance of fire is a lot less. When you get to granulation department, you're gonna see with the higher RPM, you're gonna have a higher chances for fire. That's why there are granulates in the market, which they are looking at 80 round per minute, all the way to 340, 400 round per minute. So for those of you in a tire recycling business, it is important as you go to a faster machine, consider the better fire suppression system. At this stage, we are taking the 2-inch size shred, which is coming from shredder, goes to granulation. We reduce the size down to 3/4 inch. Over 90% of the wire get picked up by magnet in this stage. And this is the cross-belt magnet, you're looking at it, and the discharge table. The next step is a secondary granulation department. When you get to secondary granulation department, now we're going to go to higher RPM, more rounds per minute. The second department, second granulation type, you're taking a 3/4 inch rubber particle down to 3/4 inch to 1/4 inch size. We're dealing with machines anywhere from 700 round per minute to 1700 round per minute. This is the area of pretty much a fire zone because you're looking about wire, you're looking at a high-speed system, and you have the wire which is in that rubber would cause a spark, and of course you still have some fiber and rubber as a fuel in the system. The next step is taking down 1/4 inch size material further down to make a chrome rubber anywhere from -10 mesh all the way to 40 mesh chrome rubber by grinding method. What you see here is cracker mill, which would this is a slow machine. You're looking about anywhere from 15 to 30 round per minute. This is a difference between us in the United States and Europeans, which there's been a great deal of discussion. Tire recyclers, Americans and Europeans. Europeans, they like to use fine granulators to produce fine chrome rubber, and they have seen quite a bit of a fire problem with that type of operation. And now we are actually exporting our technology, cracker mill technology, which is an old technology in the U.S., to European market. You're looking at finished product. I'm going to show it to you later on, the specifications, which we're looking about 99.9% free of fiber and steel material we need to produce for asphalt uses. The rubber is packaged in a super sacks in a 2,000 pounds bags. And this is how it's being transported to the project site. One of the important aspects in the tire recycling air control systems. We're dealing with high-speed machines. We're dealing fiber material get extracted from tires. How are we going to deal with that fiber? How are we going to deal with the air quality? This is our plant in Southern California, we are in the toughest air quality management district, Southern California Air Quality Management District. They required us the entire plant under negative pressure. That means the air we are getting outside of our plant, all of the air should be, we need to suck the air inside. No air can go outside of the plant. And all of the air needs to go to the bagging system, air control system to clean the air. And the measurements we made, the air we are coming to our plant, the air is going out of the stack from our plant is cleaner than the air we are sucking into our plant. So we are kind of indirectly, we are in an air cleaning business in Southern California. Chirogenic rubber, this is another way of getting down to same size of the chrome rubber. However, in this case, we are using liquid nitrogen, and I will show it to you how we produce that type of rubber. Still, we are dealing with the same type of equipment to start the whole tire. We shred it down, we go to granulation system, and finally we get to liquid nitrogen and separation of the wire and fiber, and finally we dry the rubber. We're going to see all of these steps in the next few slides. This is our new plant, a chirogenic plant in New York. It shows the whole chirogenic line. The rubber get inputted to the tunnel, and we usually use a 2-inch tire chip. It's been frozen by liquid nitrogen. We bring the temperature of the tire chip down to minus 290 degrees Fahrenheit or minus 180 degrees Celsius. The production capacity of this type of line, we're looking about 9,000 pounds per hour or 800 tires per hour. This is my technical guy. This is supposed to be, well, go back.
Apologies, it was working just a moment ago.
Well, now since you cannot see the video, you all need either come to Phoenix or New York to see the plant. Okay, I can explain it to you. The rubber chips gets frozen down to minus 290 degrees Fahrenheit. That's a glass transition of the rubber become like a glass. And it goes through the frozen chips, falls through hammer mills. The hammer mill speed is about 290 miles per hour. It's a very fast machine. And the rubber, which is at the point of is like a glass, would shatter like a glass, and rubber gets separated from fiber and steel. We go to the next slide. This should be a video too. And in this stage, which is the shattered rubber, which is separated from fiber and steel, it goes through a classification unit. In this stage, you're looking separating the fiber and steel from rubber. If you notice, we have these nozzles. You see, these are the fire nozzles. You know, it has our fire suppression system is a computerized system. We have the smoke detectors. We have heat detectors. And if any of the detectors see anything, would open up the water to the system. Again, I apologize, the video would have been a better visual for you, but some reason our computer doesn't like to cooperate with us. You got to remember, we took the chip, which was at the room temperature. We took it down, we froze it down to minus 290 degrees Fahrenheit. And within a matter of seconds, we bring the minus 290 degrees Fahrenheit to room temperature. So you're going to develop condensation. So you develop moisture in your rubber. So we need to go to a drying system. We dry the rubber to an actual dryer. So you have, in one hand, you bring it to minus 90 degrees Fahrenheit, and now we dry the rubber to bring it to dry the rubber. In a cryogenic system, pretty much when you shatter that rubber, you produce different types of rubber. And usually, based on the screen you have in your classification system, we are making rubber, namely oversized rubber 10 plus, 10, 14, 14, 30, and minus 30 rubber. Again, this is our drawing system. Again, it is a video, and it shows how we are drawing the rubber into this system. We're going to get to some of the technical aspects as a rubber producer, what we need to be concerned with, and this is how we communicate with agencies. This is a green book, which is namely is being used by cities and counties in the state of California. This is Arizona Department of Transportation specification, and you're looking Caltrans specifications. So these are three of the examples in front of you. But as a chrome rubber producer, you need to have a flexibility to produce different specification, different gradation, and different properties. And it's important the rubber producer have that line of communication with your customers, with the line of communications with specification writers, designers. Because we even in the rubber asphalt, they can change the gradation on different projects. So if you're producing chrome rubber for asphalt, don't assume every agency have the same specification. And I will show it to you what that impacts the performance of your the asphalt. Green Book, which is used by cities and counties, has the requirement CO chrome rubber modifier shall be ground and granulated at ambient temperature. They do not allow cryogenic rubber. Chrome rubber modifier shall be contain less than 0.01% wire by weight. Chrome rubber modifier shall not contain more than 0.05% fiber by weight. This is where it comes to what our industry, chrome rubber industry, going to its maturity. Oftentimes, the chrome rubber producers, they don't read the specifications. The rubber goes to the job site. In case of California, if it goes to a state job, Caltrans inspector shows up, take a sample, and your rubber fails. And immediately they stop the project. Your contractor, your customer calls and says, wait a minute, my project is stopped, and you're looking about $5,000 an hour liquidated damages. So if you are producing chrome rubber for asphalt, you need to be aware of those liquid damages are for real. It's going to come to you. So making chrome rubber based on the specification required by you is a must. In California, we have specifications which they require a scrap tire, 75% scrap tires, and 25% high natural rubber chrome rubber modifier. What is the difference between high natural rubber and scrap rubber? Number one is a different gradation. Scrap tire rubber, namely, is minus 10 rubber. You're looking about 98 to 100% passing 10, and you got number 16, 45 to 75%. These ranges are very important on the mixed design of the asphalt rubber. So again, as a rubber producer, you need to be aware of the importance of these ranges and make sure you produce the rubber which was asked for. By the way, this is the range by a specification. When your contractor asks you for a sample, oftentimes mixed designs are prepared 3 up to 6 months before actual production of the project. They ask you a sample. You submit that sample to our design engineers, to agency, and the mixed design was designed based on the sample you provided 6 months ago. So when you're producing that rubber for the project, you submitted the sample, for instance, in February. The mixed design was already done, and the project goes to construction in August. Now the chrome rubber you're supplying in August do not match the mixed design or what you produced in month of February. You're going to have a problem. High natural rubber is a finer rubber by gradation and by chemical analysis. You're looking about pretty much minus 16 mesh rubber, 95 to 100% passing 16 mesh. By the way, people that talk about only by nominal sizes, 10 mesh, 16 mesh, each of these sieve size also is important on the performance of asphalt rubber. The difference between high natural rubber and scrap rubber is on the amount of natural rubber in chrome rubber. High natural rubber requires the amount of high natural rubber shall be between 40 to 48%. Scrap rubber is anywhere from 15 to 39%. So when you're dealing with high natural rubber, you have to make sure your rubber within the content of your natural rubber is between 40 to 48%. Of course, there's other requirements. You're looking about hydrocarbons. Hydrocarbons is nothing more than the amount of polymers in your tire rubber. Minimum should be 50%. So 50, because in the construction of tires, you got clay, you got carbon black. At least 50% of the rubber you're supplying should have a hydrocarbon. Acetone extract, it should be between 4% to 16%. This is the amount of oil in your tire. Brand new tire, you're looking about 16% acetone extract. Older tires, dry tires, you're looking about minimum 4%. This applies to some of the old tires in a legacy pines. If the tire is about 100 years old, probably will not going to meet acetone extract requirement. In the construction of rubber as asphalt, you're looking about, in average, in asphalt rubber, we are recycling 3 tires per ton of the asphalt rubber hot mix, 4,000 PTE per 1 mile of road, which is a 2-way road, or 2,000 tires per lane mile. This is getting a little bit technical, and I think could be even belong to other room, but I think we as a rubber producer, we need to understand why the gradation is important. What happens? This is a cross-section of the asphalt pavement. This is your aggregate, this is asphalt binder, and this is your rubber chip, the chrome rubber. That 75% scrap rubber we talked about work as elastic aggregate. And it works between 2 aggregates as elastic. That's why we have a high, good elasticity in asphalt rubber pavement. And chrome rubber, which is finer chrome rubber, goes and modify the binder. So it's a two-part, pretty much is a two-part system. We modify the binder, and also we make the mixture more elastic. This is a discussion we can have later on. The people were talking about the terminal blend versus a wet system or asphalt rubber system. Asphalt rubber system is a mixture system. It takes care of both binder and mixed properties, which is in the thermal blend, you're only dealing with the binder properties. They both are good product, but you're looking about, you want to have a Bentley or you want a Cadillac. You want a Bentley, that's what you're looking for. The other important factor here, if you notice this rubber, of course we went and painted here, it may not be like this in actual mix, but a good proper mixing is very important. So it's important this rubber plays in a void is being allowed for that rubber. So if you have a rubber which is a clumpy rubber do not disperse, most of these rubber will be sticking together. So if you get a rubber-to-rubber contact, sometimes you're going to see a premature potholing. If you get to rubber contact, and that's an area which you're going to see potholing. So we as a rubber producer, we know what we have done. So we should take responsibility on the type of rubber we're producing. Producing chrome rubber for asphalt is a technical subject. People they say, okay, rubber why this gradation is so important? We put the rubber in the mix, we cook it, the rubber get dissolved, so it doesn't matter is it 10 mesh or 30 mesh. No, the rubber do not get dissolved in asphalt binder. And this is the proof for it. You can do this in any of your laboratory facilities. You mix the rubber at a high temperature, up to 400 degrees Fahrenheit, that's pretty much most of our asphalt. That's a flash point for asphalt. And you can retrieve over 95% of the chrome rubber you put it in. So the rubber do not get dissolved. That's why it is important, the size of the chrome rubber. It is important, and we do not really want to dissolve the chrome rubber in asphalt. Think about it. The chrome rubber goes from all kinds of different tires. When we process tires at 600 to 1,000 tires per hour, we cannot distinguish tires between Michelin, Goodyear, Firestone. It has almost different chemical properties. And also you're looking with asphalt crude, which is not a consistent product. When you bring these two products and you want to make a chemical marriage, you may have other problems with that binder. We want to get the benefit of elastic recovery of the binder. We do not want pretty much get rid of rubber in asphalt. This is the recovered after we mixed it. It goes to mixing chamber. We cooked it, cured it over 24 hours. We managed to get the rubber out. And again, the test is a very simple test. There are certain chemicals you can dissolve asphalt, and you can get the rubber. And we had a paper, we gave it in Brazil, which we managed. Actually, we showed the chemistry of the asphalt before and after was the same. And also the mechanical properties of the binder was the same. The gradation of rubber before and after was the same. As a chrome rubber producer, you need to have your own laboratory facility. You need to do your own testing before you supply it to your customer. This is a sieve analysis. We actually we partnered, industry in California partnered with Caltrans for 3 years to develop a proper testing method to do sieve analysis on chrome rubber. And we developed that as standard. It was an industry and Caltrans cooperation. Okay, what happens if your rubber is out of gradation? What happens if you have a quality problem? It impacts your compaction. If it impacts your compaction, you're going to have early failures, premature failures. This is the rubber sacks. It's been going through this screen at the hopper, at the contractor site. These are some of the problems we have seen because of the chrome rubber problems. This is a segregation problem. You see on this project, we have seen some pickup problems by a roller. Again, this had to do with chrome rubber problems, and you can see this gentleman is actually watching the chrome rubber going through the hopper, make sure that the rubber is not clumpy rubber. And of course, we all focus so much on temperature. When we're making compaction, we all think about temperature, headed hot, compact it as hot as you can get. However, if your basic products is not within the specification, temperature is not going to be a solution to your problem. This inspector is so focused on getting the rubber, asphalt rubber, break it down and roll it down at a high temperature, but we should, if you have problems out in the field, temperature could be one of the problems. Mixed design could be another problem. Aggregate size could be a problem, but chrome rubber also do play a role in the performance of your asphalt pavement. And finally, this is one of our projects which we did in New Jersey. The people, they knew we were going to do rubber as asphalt. The day we were doing rubber as asphalt, they brought the whole tire. They put it on the sidewalk, and it says, we're going to recycle tires. No, you cannot recycle a whole tire, but that needs to be processed. Some of other projects we did, a pile of the tires we did on other states, went to the asphalt, and finally, we're looking about over 25 years working with the industry to make chrome rubber, which make our asphalt last longer. So production of chrome rubber, in conclusion, production of rubber has impact on the performance of asphalt rubber. And if you have any question, I'd be happy to answer you. Hi.
Yes, my question is, when you talk about high natural content chrome rubber modifier product, when you talk about this type of product, you are talking about tires, chrome rubber that come from truck tires.
It can be truck tires as long as it meets the natural rubber specification, which is required minimum to be 40%. Now, and also, you saw there is a maximum of 48%. We got to be careful. We don't want 100% natural, high natural rubber because it makes the binder very viscous.
Excuse me?
It gets the binder, if you exceed 48%, the viscosity of the binder, it exceeds, and you're going to get to workability problems with your binder. Yeah. So it's a minimum and maximum. But it can be, as long as truck tires meets the requirements of this specification, it can be truck tires that's allowed in the specification.
Thank you.
Sure.
I have several questions. Well, first of all, when you talked about the fire hazard, are you referring to the elastomer or the processed oil, which may catch on fire? That's the number one question. The second is most passenger tires are SBR natural rubber. 75-25 is about the average. So if you use passenger tires only, you don't get enough natural rubber. Is there enough truck tires recycled to get you natural rubber? And if it's not, where do you buy the natural rubber to add to your mix?
Let me answer your second question first on the source of natural rubber. You're right, most of the passenger tires do not meet the natural rubber requirement. Truck tires do meet some of the requirement of 40%. The other type of sources we're looking about aircraft tires, it has a high natural rubber content. If you go to aircraft tires, and if that's not available for you, there are other sources of high natural rubber, namely it's come from shoe manufacturing or tennis balls has high natural rubber.
Well, I looked at your equipment, for instance. If you have, for instance, earth-moving equipment with those huge tires, can you recycle those? Is there somebody who cuts them up first to small enough sizes so you can put it in your conveyor belt? Or what do you do with these huge tires?
Okay, OTR tires, you can recycle OTR tires. What they do with OTR tires, they buff them. It's like a buffing truck tires. They buff, OTR tires got lots of good rubber on the top of it. You're using a buffing method or peeling method. They peel, they thread away from carcass, and then they would shred the carcass part of it. But you cannot, again, what depends on what you mean by OTR tires. The OTR tires I'm talking about is 6 foot.
Yes, yes, exactly.
And those are the tires which there's not such machine you can take the whole tire. You would peel away the rubber from tire, and you chop the carcass and you dispose the rest of it.
And one more question. If I remember from last year in a presentation in San Antonio, they said once the rubber is added to the asphalt, they have 3 hours of residence times allowed before they use the mix. If there is no chemical interaction between the asphalt and the rubber, why is this 3-hour window so important?
It's not a chemical reaction, however, it has a chemical interaction. There's a difference between reaction and interaction. You develop a swelling of the chrome rubber in asphalt. In our specification, it requires 45 minutes. And if you mix the rubber with asphalt, check the viscosity. You can see the viscosity between 0 minute and 45 minutes goes up, and it gets to optimum. You're looking about our specification require minimum 1,500 centipodes. So you need that curing time to get that interaction between chrome rubber and an asphalt happens.
So you say that it needs at least 45 minutes residence time before it's applied?
Yes, that's the requirement in the specifications.
Thank you.
And you had the first question on fire.
Oh.
The question on fire, as I explained to you, we talked about 3 different departments: shredding department, granulation, grinding. As you're going to get to higher RPM machines, is a rotating with blades. If you're looking about high RPM machines, 1,700 round per minute, because of that high speed and in the rubber particles, still you have some wire mixed with the rubber. That high speed cause a spark, and you have rubber as a fuel for cutting on fire. So if you are in this business, as you're dealing with a higher speed machine, you need to consider fire suppression system. And its fire suppression system, there's no good fire suppression system if you don't maintain it. Just putting detectors and do not maintain it, and your people do not have a proper training as well, you're developing a false feel of a safety. You think your detectors are there and it's not functioning. Detectors is nothing more than electronic eyes watching for that spark. If those electronic eyes are covered, it's not being maintained, so it's not going to see the spark. As a result, you're going to have a fire. I would emphasize this sophisticated systems training of your people, because most of our plants running 24 hours, 7 days. You're looking about 2 o'clock in the morning, a fire happens. How people are going to handle that? The best prevention, fire prevention, is that first 10 seconds, 1 minute, you can put it out. If you're waiting for fire department to respond, it's too late. It's very late. Yes.
Dr. Takallou, I was just interested in the high natural rubber. and I know that you're familiar with a lot of different specifications from agencies everywhere. Do all agencies require high natural rubber in their specifications, or can the material be designed and produced without the addition of high nat?
California is the only state to require high natural rubber. Arizona specification do not require high natural rubber.
Hi, my name is Lance Brown with Caltrans Maintenance. My question is related to the PTE, the passenger tire equivalent. First, the slide you have up on the screen right now says recycles 4,000 waste tires. What's that based on?
Per 1 lane mile to 1 mile of road, 2 lane,
Okay, so that's 24 feet wide. How many inches deep?
2 inch.
Okay, that's what I assumed. So the passenger tire equivalent, what basis is that 3 tires passenger tire equivalent on?
Based on 10 pounds of chrome rubber per PTE, because what we know, there was a presentation this morning, we were talking about 20 pounds per PTE, but most of passenger tires we're rating is about 18 pounds. And you're looking about 10 pounds of recovered rubber per PTE, or 30 pounds of chrome rubber for 1 ton of asphalt. So you're looking about, if it's a 2,000 tons of the mix, based on 1.5%, you're looking about 30 pounds of chrome rubber per ton.
Okay, thank you.
In California, I know that the different cities and counties will offer scrap tire collection days where the citizens can bring in their scrap tires. And many times they put a restriction that the tires cannot be on the steel wheels. What additional problems does that create, and what, if any, equipment is being developed to deal with the scrap tires that still have the wheels on them?
I don't know. No, I don't know why they make that restriction. The equipment to get the rim out of the tire is very basic equipment. You crush the rim. As a matter of fact, we like the rim because it has a good resale value for scrap steel. I hope Waste Management Board, whoever making that restriction, lift that restriction, because as a tire recycler, you should be able to recycle everything. And having a rim in the tire is not a problem. Of course, we're not going to shred the whole thing. We do get the rim out first, and then we shred the tire. And of course, we sell the rim. Thanks.
Back here, Barry. Some in California have expressed concern that there's a shortage of supply of crumb for different products. I'm wondering if you are experiencing that. Some have also suggested that RAC might be driving that. I'm wondering if you agree with that as well. And if you do you find that in other states or only in California?
Our business is a seasonal business. Of course, we have seen increase in the RAC consumption. What's happened this past summer, July and August, our customers book all of the project and they want to pay all of the project month of July. And they do not communicate that with their supplier. So this year we're gonna go with working together with our customers. No problem. If you need that much rubber, predict better, forecast better. Even our customers, contractors, they got off guard with the amount of business they received this year. There is some sort of a shortage of rubber, but it's not as much. The market is talking about. I believe there is a good balance between capacity and supply now. Is mainly a function of scheduling needs to be worked with, and suppliers and consumers, they need to work on a better cooperation scheduling their demands.
I'm from the state of Nebraska. I wanted to answer the question or address it about the restriction on wheels on and rims on tires. We do have that restriction in Nebraska, but we pay for the amnesty cleanups across the state. The reason is because most places want to charge $1 to $2 to have that rim removed, and as a state, we don't want to pay for it. And also, the haulers just want to load up tires and go and then remove them some other place, and we pay by the semi-load. The rim is going to double the weight in the case of a passenger tire, so that's why we say no rims can be brought in.
Yes, just a question. I will know if have you a method to determine the amount of steel in the steel and textile in the rubber. There is a method.
To recover more steel and recover more textile?
No, just of point of view laboratory test. So if I give to you a sample of my product, can you how you determine the amount of steel? There is a method to follow?
There is a method, and the method is a very basic method, is a magnet. You know, we get 100 grams of a representative sample, use a magnet, and you see how much you're collecting in steel on that magnet. Fiber, throughout your sieve analysis, you're gonna collect the fiber in your sieve, and that's how you would extract the fiber for your determination of the fiber content.
I agree with you for fibers, but for steel I don't agree with you, because when you pass your magnetic engine or whatever, you take off not only the steel, but also steel with rubber.
If you're down to that size of 10 minus, the rubber and the steel are not embedded together anymore. You're gonna see free steel. I don't believe you're gonna see the rubber and steel together anymore.
Our experience is really. We think that the best method maybe is by carbonization, something like that, you know. Because if not, the amount of rubber you do take off with the magnetic is high. Is really high.
It depends to your application. We got Mr. John McBride from NASA here. If you're using rubber for very, very sensitive application, of course you go to more sensitive test. We're talking about asphalt here. Chrome rubber for asphalt, I think that would be sufficient for asphalt.
Yeah, but specifications are very 0.01% is not easy to get it.
We are achieving that, and I think not only ourselves, our colleagues, fiber is more problematic than steel for us.
To me, it's much more easy take off fibers than take off the steel. In this average.
If you have time, we have a plant in Los Angeles. I'd like to show it to you how we do it. Our final check during our production, how we get the steel out. I'd be happy to show you what we do.